Okay, so in this lesson, we are going to try and prove the idea or the concept of the area of triangles. Also, we'll be applying them in vectors. My name is Bright Pamela Grant, and the line. Let me send you the link. Share the link. Okay, so let me use the Aquila book as a reference. Area of a triangle. So, we'll look back at 20. So if you have a triangle like this, right? So you follow the triangle that they are using here, ABC. Now in vectors, when you are labeling them, you have to label them in a clockwise direction or anti-clockwise direction, right? So clockwise means you are moving anti-clockwise, koha, koha, baha, or you move in a clockwise. Move one, two, three. Are we okay? You don't just label them. Now, given an angle theta here, oh, given an angle theta here, right? Want to find the area of triangle ABC. Now, the area formula we know is half base height, but there are three formulas you can use to find for area of a triangle in geometry or in vector theory. You can even have another one with straight lines. There's a very long formula, but that's a proof for another day. But I want us to stress on the half base height, right? There are three formulas of triangles. The first one is what half times base times height. The second one is the what half AB sine theta, where theta lies in between what A and B. So A and B, and the theta lies in between them. And the third one is the Heron's formula. Heron's formula states that given any triangle ABC, or should I use distances? If you have a distance ABC, right? You have distances. The area is equal to the root of S, S minus A, S minus B, S minus C, right? Where S is the same as A plus B plus C all over what? 2. Are we okay? Have you ever seen this formula before? Have you seen this sample before? Yes, that's the Heron's formula. Let me see if I can get you this thing. Heron's. So that's it. Root of S, S minus A, S minus B, S minus C, where S is what? A plus B plus C all over 2. So when you find yourself struggling somewhere, these are the three types of uh, area of referencing, area of triangle that you can use. Are we okay? Now today we are going to focus more on this element, this part, right? So if we've been given any triangle, I'm cleaning with you. Have you made screenshots on it already or screenshot it again? Okay. Now we want to find the area of triangle. Now we know that the area of a triangle is what? Half times base times perpendicular height. Not just any height, perpendicular height. Okay. Now, with this triangle, no, we don't know which one is the base, we don't know which one is the height because there's no 90 degrees anywhere. Right? So we can create our own 90 degrees over here. Right? Becomes our H. Now with this H that we have given, that means that AB is the base. So now AB is base, right? But the height too, it is arbitrary. But we can use a technique with what? Pythagoras theorem, right? To find the height. So from Pythag, right? You take this triangle into consideration. When you take a for instance, this triangle, one, two, three, where this is your H, this is your theta, here's your 90, right? Mind you, this becomes we want to use this height and this distance, let's say AC, right? As because we don't know the value of this part, this distance, we don't know the value. So the only thing that we know is that we know that this we can measure AC, right? So let's take as if AC is Y. Okay, you let me maintain this thing the magnitudes, right? Now we know that to find the value of H, you can use Soka Toa, or let me say the tree version. I like the tree version. Toa Soka. So Toa Soka, right? So with Toa Soka, what do we have in the diagram? We have this side opposite to the angle. So opposite, we take opposite, another opposite, right? And we have what? Hypotenuse. So hypotenuse. So the one with the two correct is one we will use. We are going to use sine. Are we okay? Hello? I mean, so do you know why we are using sine? Because we have the value of AC. Maybe AC is given in the diagram, right? We are trying to express the height in terms of the angle. So in this case, sine what? Sine theta becomes opposite over hypotenuse, which eventually becomes what? The height over AC. Are we okay? Now, because we introduce this red line as our hypotenuse, as our height, perpendicular height, if we are going to substitute it into the formula as given, we have to make H the subject. So AC sine theta becomes H. So area of what? The triangle now becomes half base. Now we know the base is where the height is sitting on. That is A times height. But now your height is now what? Something else. AC sine theta. So it becomes AC sine what? Theta. Okay. So everything here is the same as your what? Half base height. This is your height. This alone is your base. Are we okay? So in general, what we can say in summary is that anytime you are given a triangle, right? A, B, C, whether A, B, C or anything, and the angle is between one side. The angle is between two what? Two lines. Like this, there's an angle here, another angle here. In between these two lines, the area of the triangle becomes what? It becomes half these two distances, multiplying them, right? So you can say AB times what? AC, sine of the angle between AB and AC, right? this angle between two vectors or two lines, we'll come and see it again in the proof of what? Perpendicular vectors. In perpendicular vectors, we'll come and use the same idea. So now you understand why this formula came about. So if I give you something like this, 4, 3, and I give you an angle here, let's say an angle of 60 degrees, what will be the area of the triangle? The area of the triangle is going to be what? Half 4 times 3 sine what? 60. Are you okay? Because the 3 sine 60 stands for the height, stands for the perpendicular height. Mind you that it can be 3 sine 60 or 4 sine because 3 and 4 they are commutative multiplication. So it can actually be half 3 times 4 sine 60. But the sine is just standing there for the perpendicular height relative to the what? The hypotenuse of this right angle triangle. Are we okay? Okay. Going to something else. We have parallelogram to proof of the parallelogram. So you can screenshot this one too. Okay. So if I give you a triangle like this, triangle, I'll give you a triangle like this, right? And I give you 40 degrees. I give you uh, 3 units. I give you um, should I use this one? 4. I'm just giving random listing. What will be the area of the triangle? In such a triangle, what will be the area? Yes. Yeah. In this case, we've been given the measurements already. No, no, it's not 4 times 3. Where is the angle? Where is the angle? It's in between which two numbers? 4 and 7. So where the angle lies between, so if you look at the preamble, you see we have A, B, and A, and the angle is in between these two lines. So where the angle lies in between, that's the value that we are going to use. So is it, how do I write this now? 7. 4 again. No, we are using sine theta. No, let me explain it again. Seems you're not getting it well. Now let's look at something. Whenever you are given a triangle, right? You are too much your focus is too much on the AC and the AB and those things. Let your focus just come on where the angle lies. In this case, angle is in between what? This distance, this distance, and this distance. Are you okay? So if the angle is related to these two lines, the area is going to be what? Half the product of these two lines, 4 times 7, sine 40. Are you getting it? Okay, so if I put another angle here, maybe 20 degrees, right? What is going to be the area? Let me clean this angle. What's going to be the area of the what? Of the triangle? 3. Sine. Are you okay? Okay, what if I change the angle? And I put the angle here, maybe 50 degrees. What's going to be the area? and you 50. Are you okay? Very good. You come and apply this concept again in sine rule and cosine rule when you start doing the Lamis theorem and those stuff. So you can make a screenshot of this one. Okay. So now let's go improve parallelogram. Parallelogram is just a slanted rectangle, right? If I get my parallelogram right. Something like this. Now two sides are equal, two sides are parallel. See the two lines that we've placed here. They're just telling you that the ones which are 1 1 are equal and the ones which are 2 2 are equal. Now they are also parallel. So this and this move in one direction, one to move in another direction. That's why some of the arrows are 2, some of the arrows are 1. Now with parallelogram, when you are labeling them, you should label them in according to clockwise or anti-clockwise. So A, B, C, right. Now if you want to find the area of this parallelogram, you can see that we can bring a straight line here and we get two right angles. Sorry, two triangles, right? So these two triangles, they are symmetric about each other. Or let me confirm this. Uh, fencing. Uh, yes, I want diagonal. No, a general parallelogram is not symmetrical about its diagonal because folding it along the other side doesn't make it does not make two halves, so they are not symmetric. I wanted to confirm. One thing I know is that the area about the parallelogram has been equal area. Yes. Now you say that any diagonal of a parallelogram divides it into two triangles of equal areas. Now this is the point where we are going to use very much. When you create a diagonal between parallelograms, their areas become equal, right? Because the diagonal has a common side and the opposite side. So now let's go and use that justification. This means that this area is the same as this area. Are we okay? Now, from our theorem of triangles, parallelograms too, they come along with their angles, right? So you can put an angle here. Let's say the angle here is theta, right? So the area of parallelogram is going to be what? Two is this area plus this area. So it's the same as the same. And you see, parallelogram to they have opposite angles. So what is here as what is here. So just add them together and you get two. So it becomes two times the area of one triangle. It, what's the area of one triangle with respect to the what? The angles. So area of triangle is half. Now the angle is in between which side? No, come again, come again. This is the angle. Oh. See, look at something. If they ask you where the angle is in between, you start to draw an arc from this line to this line. So the angle is in between this line and this line. It's in between this line and this line. So now what is the angle in between? According to let me say from triangle ADC. So this becomes 2 times half. Now we are going to use this triangle. So what do I write? In terms of this, he said, okay, I want to use this triangle alone. This triangle. One, I'm drawing a line. I want to use this triangle. This, this. Find the area of this triangle. Multiply it by 2. Then I'm good to go. Now the angle is lying in between what? AD or DA and DC at distances. Are you okay? So if I want to find the area of this triangle, how will I do it? From what we just learned, I want to find the area of that triangle. So 2 times the area of the triangle. Now, this is the triangle that we are talking about. Here is AD, and here is DC. And this is the angle. So we are going to use their distances. So 2 times what? Half distance A, what? AD, right? Times the distance of what? DC, sine theta. Are you getting it? So now, but you see that 2 and half will cancel each other. Then it eventually becomes AD times what? EC sine. So this becomes the area of the parallelogram. Yes, are we okay? So now what we know is that DC and AB are the same, and AD and BC are also the same. So this becomes the area of the parallelogram. So if I give you a parallelogram like this, right? I say here is 4, here is 7. And I give you an angle here. Let's say, let me give you an angle like 50 degrees. 50 degrees. What would be the area? Why? Very good. So this one also becomes 50 here. And now 50 lies in between 4 and 7. Then you are good to go. Are we okay? If they say find a triangle, if there's a diagonal and find a triangle, you bring this diagonal, it becomes this, and just half of it. Very good. So let's see if we can solve some questions over there. So, yes, we move here and go. Ali, yes, we move here and go. Screen touching the problems. Have you considered? I don't know why it's still going back. Let me say bring to front. Let's attend the machine. Let's do it. Question is Police they are chill. That's up. You see, a parallelogram has vertices one, three. Then. So let's draw the parallelogram. So A, B, C, D. One, three, negative two, five, 1, 8. And we don't know the vectors of this, so let's say x, y, right? Now, I'm also then find the coordinates of what? The vertex D, right? This one is very easy. You know that from parallelogram, AB, A is the same as what? DC. Mind you, of the direction, it's AB, same as DC. So E minus A equals E minus D, new minus old, new minus old. So what is B? Negative 2, 5 minus A, 1, 3 equals C. We don't know C. Minus D. We know that A. We know C. We know C, 1, 8. But we don't know D. He said, can you say something? Okay. So this becomes negative 3, 2 equals 1, 8. Okay, I'll show you a partial fraction. Minus D. We want to make D the surface, so the D will move, becoming D equals 1, 8 minus negative 3, 2. So D 1 plus 3. 8 minus 2 is 8 minus 2 is 6. Minus 8 minus. And this becomes the vectors D, which is what? 4, 6. Yes. So that's the answer. Right here. 4, 6. The labeling is very important. A, B, C, D. You have to move whether in a clockwise or anti-clockwise. It's me, I move from the top. A, B, C, D. Quite that. Okay. Hey, may I class? So I'm kind of by YouTube. Uh, yes. So let me send your homework. Three one and be now. Which is the brain I was sending it to Abino. And you sent how many? All the 7. Okay, you have okay. Jana so that's I didn't really know say me movie me bro. Me say ya me ben ni ya me ben de bia o ya de fufu. Yes. Now, no, below no. Parallelogram. Find BE. So BE, right? DA is 3, 4. So DA is 3, 4, right? and CE is 2, 3, 2, 3. Find B. Now, to get to B, you can go and pass through what? Back part. Come and pass through here, which is BC. Then add the CE, right? But B is negative of this one. It's not in the same direction. So it's an opposite direction, so you negate it. Understand? So from the diagram, I don't want to draw the diagram again. I'm tired. From the diagram, BE is what? Coming back to BC plus what? CE. You get it? But BC is negative of what? DA. The vector DA. D from D moving to A. Over here. So it means that if you're going to really write it down, BE is now going to be what? Negative DA plus C. And negative DA is what? Negative 3, 4 plus C, which is what? 2, 3. Negative 3, 4 plus 2. And negative 3 negative plus 2, which eventually gives you negative 1, negative 1. Therefore, B vector BE negative I. Or you can leave it in the same app. Or you just go look at the solution. Yes. Hey, we made a mistake somewhere. Negative 1, negative 2. Let me check. F5. Ah, it's 3, 5. Sorry, sorry. This one is 3, 5. This one is 3, 4. It's another 3, 5. Okay. So if it becomes negative 2. Okay, I think you can call it a day. When we meet again, what are we doing? Let's move on. The rest is parallelogram. We do more of the parallelogram examples. And that's it. We're done with the vectors in a plane. The rest, maybe you solve odd numbers of the review question. Solve the odd numbers. Okay. Okay, so the next time we are meeting, we are doing more of these questions at random. The ones we think you find difficult. Then we start with the scalar or dot product, where we are going to use the angle stuffs. That one I really like it. After that, we start with the mechanics part. What you've been waiting for. The mechanics part. Send now open the vectors now. I bet that one is commerce. So no can some from Babu. I be writing emails rather. Emails I don't we don't bring those questions. A graph will be histogram. You go through. So you can call it a day. Let me switch off my YouTube.